What's going on, ladies and gentlemen? Taking a look at some of the severe weather that's going on in Oklahoma currently right now. I wanted to bring this live stream up for the National Weather Service's data that we're looking at right now as far as the current conditions. Right now in Oklahoma, it's 79 degrees, and we're looking at 65 in dew points right now. So it's hot, it's wet there. That is the breeding ground for the conditions for severe weather to roll out as far as well as the atmospheric instability that's going to be happening there. You can see these CAPE levels already at 1,000. That's going on right here. I mean, upwards of 1,000. Probably looking at around closer to 1,200 as far as the CAPE is concerned. And that's probably what it's looking like. You can see that line that's going on right there ahead of the front, or rather behind the front, or right on it actually, where the storms are kind of breeding up. All right, so wind shear is up there at 80 knots. Looking at an 80 knot wind shear that's going on into that area, so that means that it's going to supply plenty enough wind for things to roll out, for severe weather to happen. I'm sorry, I got my son playing VR here in the background. Sorry about the extra noise. All right, but surface vortice, like I said earlier today when I did the stream here, the surface vortice was going to jump up a couple notches. And it definitely did that. This is the current conditions for surface vortice here. So you definitely got a wide sector here of surface vortice conditions where you can get storms really, cranking up and really spinning in here with that storm that is moving through Oklahoma right now. Supercell composite down here is pretty high. You can see those deep blues that's going on in the southern region of Oklahoma right there, all the way through Texas. Texas could see some of these storms as well with those kinds of supercell composites. This is tornado parameter. Now, I haven't looked at this yet. This is the first time I'm looking at this as of now as far as the current data, but that is a lot of indice, a lot of high indice for tornado composite or tornado parameter right here. So you can see those deep red areas here, 3, 4, anything above 1 is potential for tornadoes. Even up here in Wisconsin, we're getting a little bit of red right there at a level 2. And some ones up there, excuse me, some ones up there as well with some of that tornado parameter up there. So very, very high indices of tornado parameter going through this area right now. You can see right there in western Oklahoma, west central, kind of Oklahoma, around Lawton, and bordering just north of Wichita Falls, it looks like right there. A lot of really high concentrated tornado parameter right there. EHI doesn't look as high in Oklahoma right there, but we do have a lot of it down on the coast of Texas down here. But still, even with these greens right here, that could give it just enough helicity to spin up some really decent severe weather in that area. And the LCL height, of course, is 750, 500. It's low LCL height. So let's go over to our HRR model. This is the current data look for the HRR model right now. You can see that narrow line of storms that's going from Oklahoma down into Texas right there. We're going to take a look just ahead of it at the sounding data and see what we got going on. Take a look at it here. So we do have tornado risk with here. Nice stable wind field. We've got the broken cap, moisture going up into the air, a little bit of heat that's up there as well with that 79 temperature. 2,100 in CAPE. It's about what I was figuring. Is it says 1,000 for the surface-based CAPE, but we're looking at closer to 2,000 actually in CAPE. LCL is low enough. So this is kind of a little bit of a more mild tornado risk actually, but it definitely does mean that tornadoes are possible in that area. I'm going to take a look a little bit further south on the line, down into Texas, and see what the indices are saying there. And a lot bigger cap, a lot bigger of a broken cap. With the moisture that's going up in there, stable wind field, significant supercell development, but not very high on the tornado spectrum as far as its formation there, tornado genesis. So let's look at these northern cells right up there. So we looked at the middle, the top, and the bottom. It looks like the tornado risk has come down a little bit from what we saw earlier today, but that might be that it might be a recycling factor, because sometimes what these storms do is they burn off all their energy trying to organize, trying to get spun up, trying to organize, and they burn off all that energy, and then they have to recycle and they have to start all over again. And that might be what's happening here. We have a little bit of that leftover stability that's going on in the atmosphere. and that's maybe just enough to hold it out from making really, really big tornadoes or severe things going on. But let's roll it on the models a little bit further. You can see those deep reds that are coming in there, and the big line of storms right here. See these Boeing sections, a lot of looks like a lot of inflow jets that's in there. All right, and so right here you can see that little inflow notch that's right there. Might be some inflow in here. The wind fields are definitely surprisingly, they're surprising me. I took a look at the radar as far as the wind, and I'll show you that in a little bit, in a minute here. And that inflow and those crosswinds, you got those northwesterlies coming in with those southerlies, and they're definitely wrapping, and that can really get supercells screaming up to the top. So let's take a look just ahead of this line. I'm going to look right about here, right in the line of Texas and Oklahoma, see what it says here. So about the same as what we're seeing, where we have a tornado risk, but it's not as high as what we were seeing earlier in the day. But the daytime heating is really causing a problem, because all that leftover daytime heating, it might have been kind of cloudy up there. Okay, hold on a second. Where did we look at? This is going into the overnight hours, 02Z. I just looked anywhere ahead of this line, and it seems like it reaches this pocket of massive instability here, where you got this 19.8 supercell development. It says weak supercell development, but supercells are definitely possible in this frame right here. So we got a broken cap, we got moisture, we got heat going up into the atmosphere, got all the ingredients, stable wind field. It's a little bit lower on the spectrum, it looks like, as far as the surface-based wind, uh, but it's stable. There's no disturbance, there's no mix-up in it or anything like that. It's going to be stable enough to get some supercell spin in here. All right, so you can see from here all these inflows. You got a little inflow notch right here. Let's take a look just ahead of that inflow notch, see what we see here. All right, so this is where we're going to run into a problem here, is into the overnight hours, where you're getting a massive amount of instability in the atmosphere right now. Got significant supercell development in this, and you got 17.0 on supercell development, over 1,000 in CAPE, almost 1,500 in CAPE, and it's reading out PDS Tor. So this is a particularly dangerous situation, tornado threat. So this is the time frame here where you could get some serious tornadoes. Now I'm going to go just south of that, just over the border of Texas, and we're reading the same thing. Not much of a break in the cap, but still a broken cap. You got a lot of moisture going up in there. You got fluctuating heat that's going up in there, but we got 20.4 in supercell development and 2,300 in surface-based CAPE here. So that's pretty significant. So in the overnight hours here, definitely going to want to be on your A game with paying attention to the weather, having that plan in place for your family, getting them to a safe place, because if it rolls out with these large tornadoes, you all live in Oklahoma, you know how this works. You know what I mean? You deal with these out there living in those areas, and for those larger tornadoes, you got to be underground. You know what I mean? It's the safest place that you can be. Try to get there. Try to have a plan in place to keep your family safe. This storm here, the line of storms, see that Boeing section right there? That means just ahead of that line right there, you're going to have some significant damaging winds. That's what that tells me. Anytime you have a Boeing section like that, damaging wind gusts are going to be right ahead of that line. Doesn't necessarily mean tornadoes. It just means you're going to have some heavy winds that can cause damage. Not to mention the hail threat in this, guys. Hail threat in here, as well as the tornadoes and everything like that. I've already seen that we're getting golf ball size hail out in Oklahoma right now. Damaging hail. Please do not be outside. Do not be on the roads. If you are on the roads, go home. Get to a safe place. Find shelter. Try to, get someplace safe. You know what I mean? A lot of heavy torrential rainfall is in this as well. Get some flooding risks. You know what I mean? What do they say? Turn around, don't drown, right? So try to get to a safe place while you can, while you got a minute. You know what I mean? Try to keep everybody safe here tonight. My radar, I'm looking at. I looked at it earlier. We got looks like we got some more tornado risks, tornado warnings that are out. We got a flash flood warning that's out there. Tornado watches. We got tornado warnings out here. We got one, it looks like, right here. And this was a confirmed tornado earlier. They have backed it down to a severe thunderstorm capable of producing a tornado located near Middleburg, moving east-northeast at 45 miles an hour. tornado and tennis ball size hail. That is pretty big. You're looking at around 2 inches in diameter as far as hail. That is pretty damaging hail. So definitely going to want to be undercover. You know, get your family safe, your pets safe. You know, this is just it's a really, really bad situation tonight, and I hope that everybody stays safe. So like the wind that I was telling you about, we got these southerlies that are moving in, causing a lot of these inflow notches and everything that you're seeing here. A little bit notchy in this line, and then you're getting these northwesterlies that are moving in. And then you got this outflow boundary line that's just south of the line right here that's coming in. It's actually, you know, kind of right here behind the line of storms. But that is separating the narrow kind of passageway for that wind to come through. But you know, this is where you're getting your downdrafts. This is where you're getting your updrafts, and you got these northerlies that are kind of, you know, blowing in here. You know what I mean? So you got northwest, you got north, you got coming in from harder west than northwest, and then you got the southerlies moving in here in the inflow, and that's going to be supportive of your updrafts. All right, so this is, you know, one of those nights where you just definitely have to be on your weather aware game. So in here you can see that purple that's in there, a lot of purple that's in there, and that's all hail. That could be very, very heavy torrential rainfall or hail. That is just in that one cell right there. I mean, this thing is probably already spinning, and we can double check that here in a second, and I will look at we can look at some velocity radar data here in a minute and see what we're looking at. But let me show you the high def, because sometimes this shows up a lot better. We've got severe thunderstorm warnings all along this line of storms here. But even in, well, you can't really see the purple in the high def, but you can see that red that's wrapping there, you know what I mean? Just a big, big red section in that cell that's just really ramping up. And there definitely could be some very heavy torrential rainfall, high damaging winds, especially with the wind shear the way it is in this area. And we're already seeing it in the warning right there in the tornado warning. We're getting tennis ball size hail in some areas. Let's go back to my internet here, and I can go to this velocity radar. This is the radar that I use for it, site-specific Doppler. All right, so let's take a look here. There is that line of storms that you're seeing. This is based out of DFW right now, but you can see all those severe thunderstorm warnings that are up there. We got the tornado warning right there, and if another one pops up, this site is really good at getting them up on the spot. They get these tornado warnings up here pretty much as soon as they roll out from the National Weather Service. So you can see that white area that's right there in the middle of that cell when I take the mouse away, and that's a lot of times those are hail crystals in there. That's you know, the big hail ball that's in the middle of those cells. So you can see how much hail is attributed with this storm as it continues along. But I'm gonna go right here to Oklahoma City. So we can see this a little bit deeper. Now, the one thing that, see, you got a little inflow notch that's right here in the front part of this tornado warning, but this whole thing, I know you can't see it when I put my mouse over the severe thunderstorm warning, but this whole thing is wrapping like this, and it's kind of in this S kind of shape here, and that indicates to me that there's possibly some rotation going on. The way this is wrapping around like that looks like inflow, that looks like a little bit of updraft that's going on with that. Let's take a look at velocity radar, see what we're seeing in here. So you can see that big green ball that's in the middle of that. That's that rotation that I was just talking about. So you can see that wrapping around right there. It means that there's rotation right here, probably up higher. So they got this right at the end of this tornado warning right here, which is probably an extended tornado warning from earlier. That's what it looks like to me. So that rotation is just probably north of that, and what you're seeing right here is that RFD that's wrapping around into the inflow. All right, so that's what it looks like on the velocity radar. There's definitely rotation that is going on in there. It's not very strong, but it's definitely apparent. I mean, it's you know, it's strong enough. Now, the other thing that I'm worried about here too that I'm looking at is how close in some of these areas that these greens and reds are. And the way that this red is kind of wrapping this way a little bit, might have a little bit of rotation starting to build in some of these other areas along this line. That's right here. All right, so yeah, if you live in any of these areas around Oklahoma City and east of Oklahoma City, even west of Oklahoma City right now, anywhere in this area, you definitely want to be you definitely want to be weather aware right now, because there is storms that are starting to roll out and actually cause rotation. This is the beginning of the night, you know, as far as I'm concerned right here, as far as the dangerous situations with storms and tornadoes rolling out. All right, so I wanted to show you that, as well as the radar, and give you a little bit of a look at what we're looking at for the rest of the night. It's going to be a long night for you guys. Strap down, be weather aware. You might not get much sleep tonight, but hey, stay awake, you know what I mean, if you need to, and try to be safe tonight. Try to have that plan in place for your family, and I hope everybody stays safe, and just bear through it. So we're thinking about you. We're all thinking about you guys. Hope you stay safe tonight. Good luck, and do another weather report tomorrow on the further convection outlooks for the next 2 days. All right, thanks for joining me. Thanks for watching. Stay safe. Try to have a great